Also. Let's talk about kinetics and chemical equilibrium. Definitely, we are going to talk about chemical reactions here, since this is chemistry, no? Again, we are going to talk about chemical reactions and at the same time, their kinetics and the chemical equilibrium itself. So at the end of the period, you should be able to first define what chemical equilibrium is, discuss the factors influencing the rate of chemical reaction. And lastly, explain the law of mass action and at the same time, law of chemical equilibrium. In the laboratory, I'll be teaching you the different types of chemical reaction, and that includes class balancing equation. Ituturo ko yun siya sa laboratory. So you expect na wala muna tayong masyadong laboratory experiments. Let's have that sa midterm and sa finals. Okay? So again, we will be talking about equilibrium. Class, when you say equilibrium, we are talking about the chemical reaction that should be equal. And that is in terms of the rate. Okay? The rate of the chemical equation. Now again, when you say chemical equilibrium, it's a state in which the rates of the forward and reverse reactions are equal. So I believe we all know what a chemical reaction is. So example, meron kang compound A, pinag-react mo siya sa compound B, and then this will result to, example, another two compounds, C plus D. So this part here for the chemical reaction are called the reactants. Reactants kasi dalawa sila. And this part here are the products. Now in chemistry, you will see this type of arrow, class. If this is the arrow, it means the chemical reaction is reversible. Meaning, we have the so-called forward reaction. It is where the reactants react with each other to form the compounds. Pero pwede din natin siyang i-reverse na yung products will become the reactants. Okay, again, the products will become the reactants to form the product here. Supposedly, this is the original reactant, but they will become products in the reverse reaction. So take note of this arrow, ha? This means the reaction is reversible. It can go forward. So this one is the original reactant forming the original product, or it can reverse. The products will become the reactant, and the supposedly reactant will become the products. Now, when are we going to achieve equilibrium? If the rate, take note, it will be the rate. The rate of the forward and the reverse reactions are equal. So, gaano kabilis yung forward reaction na mag-take place, ganun din dapat kabilis yung reverse reaction na mag-happen. Okay? Or mag-occur. That's what you call a chemical equilibrium. Okay? So ito yung aking example kanina. Meron tayong two opposing reactions. If you get to see a two-headed arrow, that means that is a reversible reaction. And take note, all ionic reactions may be considered reversible reaction. So when you say ionic, this is a combination of metal and a non-metal na mga compounds. So example, let me give you an example of a reversible reaction. Reaction between hydrochloric acid plus the sodium hydroxide. Okay, yielding, this is a reversible reaction, yielding sodium chloride plus water. Let me just write water as HOH, but that is H2O. Okay, that's water. So this one is an ionic reaction. It involves ions plus, no? and combination of a metal and a non-metal, or yung salts, involvement of salt here. We have the salt, sodium chloride here. Pwede itong ma-reverse. Si hydrochloric acid mag-combine or magre-react with sodium hydroxide to form these compounds. Sodium chloride plus water. Pero pwede din natin siyang i-reverse. Sodium chloride will react with water to form, baliktad, ito na yung magiging product, hydrochloric acid and sodium hydroxide. Again, this is an example of a reversible reaction. And we will achieve chemical equilibrium if the rate of the forward reaction is equal to the rate sa reverse reaction. So, yung kanilang rate or yung gano'n sila kabilis mag-take place, dapat magkapareho. Again, for us to achieve chemical equilibrium. Okay? Or yung rate, yung gano'n sila kabilis mag-take place plus yung reaction, we call that reaction velocity. Na pag pinaghalo mo sila, pinaghalo mo yung dalawang compounds, yung reaction, gano'n kabilis yung reaction, yan yung reaction velocity. So that is the change in concentration in unit time. Yung concentration natin, meron tayong different units for our concentration. Pwede siyang gram formula weight per liter. Pwede siyang example, wait lang ha. Sulat ko siya. Pwede siyang grams per liter. Pwede siyang milligrams per ml. These are units of concentration. Okay, pwede ding percent. Pwede din, what else do we use for concentration? I don't know if you are familiar with normality and molarity. And even formality, though formality is not really that much used as unit of concentration nowadays. Ito yung nakikita niyo sa mga chemicals class. Example, may nakalagay 9N hydrochloric acid. Yung 9N dyan, concentration niya yan. And N means normal. Okay? Yan yung mga examples. You will learn that one sa mga succeeding subjects and lessons natin. But ito yung mga examples of the concentration or units of concentration. So pag sinabing reaction velocity, our unit here is syempre concentration over time. So this is an example, formality per second, pwede din normality per minute. As long as it is class concentration over time, that's the unit for reaction velocity or yung speed. Okay? So, when you say reaction kinetics, that's a special field in chemistry that studies the rate of chemical reactions. So again, ano ito, branch ng chemistry na yung dinidil is yung study about chemical rates or chemical reaction rates, and at the same time the factors that will affect the reaction velocities or yung rate of chemical reaction. Okay? Bakit kailangan natin ito studyhan? Kasi 'di ba, in chemistry, we should know if a substance reacts with another substance, and at the same time, we should know also kung gaano kabilis yung reaction mag-take place. Kasi baka may ibang substance na magre-react naman sila pero it will take longer time for them to react with each other. So kaya kasali yung rate class sa pinag-aaralan natin. Now, what are the factors influencing rate of reaction? Number 1, presence of catalyst. Anong ibig sabihin ng catalyst? How do you understand catalyst? I believe you are familiar with catalyst, pero ano yung understanding niyo sa kanya? When you say catalyst. Minsan may makikita kayong catalyst for change. Ano ba ibig sabihin ng catalyst? Anyone who knows what a catalyst is? Walang idea what a catalyst is. Sa chemistry class, a catalyst is promoter. Okay. Sa chemistry, catalyst class means any substance that speeds up a chemical reaction. Okay? Tama yan siya. Reactant or a substance na magpapaspas sa chemical reaction. Okay? Any substance that increase the rate of chemical reaction is called a catalyst. Okay? So during the reaction, they will be present in small amount and their only role there, yung role talaga nila, yung purpose bakit sila andyan is just to speed up the chemical reaction. So this will really influence the rate, no? The presence of the catalyst will really influence the rate of the chemical reaction. So itong catalyst, it will not be consumed during the reaction. Wala siyang reaction with the other substances. Okay? Nandyan lang talaga siya to speed up the reaction. So example, yung example ko na lang kanina, hydrochloric acid plus sodium hydroxide. These are the reactants. These two are the reactants. Sila ang magre-react to produce the sodium chloride and the water. Now, if gusto mong mabilis mangyari ang reaction nitong dalawa, pwede kang maglagay ng catalyst. Okay? So that's any substance. Example lang ito ha. Example, maglalagay ka ng element na platinum. Now, platinum there is not included in the reaction between the two reactants. Pero present siya. Okay? Example, sa beaker mo, nilagay mo si hydrochloric acid. Tapos nagdagdag ka ng sodium hydroxide. Tapos magre-react silang dalawa, di ba? Na kung gusto mong mabilis mangyari ang reaction nilang dalawa, pwede kang example, magdagdag ng catalyst which is the platinum. Due to the presence of the platinum, mabilis mangyari ang reaction na ito and mabilis itong mag-form. Yun yung ginagawa class ng catalyst. So wala siyang wala siyang reaction with the substances. You can see yung products remain the same. We have sodium chloride and water lang pa rin. Walang walang platinum na nakalagay. So andyan lang talaga siya sa reaction just to speed up the rate. Okay? That's the use of catalyst. Okay? So that is for chemistry. Sa human body class, 'di ba, ang body natin may mga chemical reactions naman talaga sa body natin na nangyayari. Meron din tayong tinatawag na biological catalyst. Okay? Kasi ang role ng substances na ito inside our body is to speed up the chemical reactions. Who knows here what is the biological catalyst na nasa body natin? Any idea? Yung biological catalyst na yan? Do you have any idea ano yan? Or wala? Susulat na lang natin. These are the enzymes. Okay. I believe you are very familiar with enzymes. The enzymes in our body, very good enzymes, yun yung ating tinatawag na biological catalyst. They are present in the body, inside our body, to speed up the chemical reactions. Okay? So sa chemistry, marami tayong catalyst available to speed up our chemical reaction. But in our body, we have this one, the enzymes. And yes, enzymes are mostly proteins. These are our proteins na in their presence, chemical reactions will speed up. Okay? So, meron tayong tinatawag na positive catalyst. Positive siya kasi nga siya yung mag-speed up, mag-accelerate ng chemical reactions. And we have two types of positive catalyst. Number one, ito yung positive catalyst that will form an intermediate compound with the reacting substance from which it is subsequently regenerated without a change. Okay? So, mangyayari niyan, example, you have a reactant. Okay? Tapos, you have another reactant. Tapos, maglalagay ka ng catalyst. Ang mangyayari sa catalyst na ito, magpo-form siya, example, ng intermediate compound, okay, sa isang reactant. So example, magpo-form siya ng intermediate compound dyan, meaning combination of the reactant and the catalyst. So pag nag-combine yan silang dalawa, mag-speed up ang reaction, mas maa-attract yung another reactant dito sa combined reactant catalyst na compound na ito. Now, pag na-attract siya, mabilis mangyayari ang reaction. Ang mangyayari, yung dalawang reactant dyan ang re-react to form the product. And mahihiwalay si catalyst as its unchanged form. Hindi siya magkakaroon ng changes sa sarili niya. Magfo-form lang talaga siya ng compound with the reactant, isang reactant, para mabilis ma-attract yung another reactant. That's how it speeds up the reaction. Meron din tayong tinatawag na contact catalyst. Pag sinabing contact catalyst, it will give a surface, magpo-provide siya ng surface sa mga reacting substances para mabilis din ang kanilang reaction. So for example, ito yung catalyst, para siyang magnet na didikit dyan yung isang reactant and mamamagnet din yung another reactant. And since class, magkakaroon sila ng reaction kasi pareha silang nakadikit sa catalyst natin, mabibilis mag-i-increase yung speed ng reaction. Bakit? Kasi magkakaroon lang kasi tayo ng chemical reaction pag merong contact ang isang atom sa another atom. Okay? Walang chemical reaction pag hindi yan sila nag-contact. So yung catalyst will provide a surface for contact between the reacting substances. And ang result niyan, magsa-speed up yung reaction. So ito din, kagaya sa isang form kanina, magfo-form muna siya ng isang compound with the other reactant, pero it will increase the affinity of another reactant. Ma-attract niya yung isa, so magkakaroon sila ng contact. And ayun, mangyayari na yung chemical reaction. So yun yung ginagawa ng catalyst just to really speed up the rate of chemical reaction. That's the first factor, presence of catalyst. Number 2, that will affect the velocity or the speed of our chemical reaction is the temperature. Okay, yung temperature natin. As you can see, yung mga substances natin, example, magdi-dissolve tayo ng asin sa tubig. Alin yung mas madaling ma-dissolve? Yung tap water, tapos nilagyan mo ng asin, or yung boiling water, tapos nilagyan mo ng asin? Alin doon yung mas mabilis yung pag-dissolve?
Boiling, ma'am.
Boiling water, ma'am.
Boiling. Yan yung sinasabi na temperature can affect the rate of the reaction. Kasi pag tinaas natin ang temperature class, tataas yung kinetic energy ng mga particles. So pag meron kang isang basong tubig, pag mainit yan, mataas yung kanyang kinetic energy. So definitely, anong meaning ng kinetic energy? That's the energy involved if the molecules are moving. So pag mataas yan, meaning yan, nagmo-move yung mga molecules. Okay? So mataas yung diffusion and mataas yung pag-move ng rate ng pag-move ng particles natin. And since they're constantly moving, malaki yung chance that they will have contact with each other. And pag magko-contact sila, mangyayari ang chemical reaction. Yes, magiging mas hyper yung ating molecules niyan pag mataas yung kinetic energy. And then again, mas mataas yung chance na magkakaroon sila ng contact. Sabi ko kanina, pag nagkaroon ng contact ang isang molecule sa another molecule, mangyayari yung chemical reaction. So definitely temperature is another factor that affects the rate. Okay, so please take note of this. A 10 degrees increase in the temperature will double the reaction speed or the velocity. So marami tayong substances in the laboratory na para sa atin mas speed up yung chemical reaction, naghi-heating tayo. Okay? Merong boiling or heating na nangyayari. Okay? So that's aside from the presence of a catalyst. And number 3, the concentration. Gaano karami yung particles, yung molecules present. That's the concentration. Siyempre, pag marami ang concentration class, maraming particles involved yun na pwedeng mag-react. And since maraming particles, tataas din yung chance for contact. Okay? And once they have contact, mangyayari si chemical reaction. So pag mas malaking chance, that will result to the increase in the speed of reaction. Okay, so tatlo na yun ha, ang mag-a-affect ng reaction velocity natin or speed of chemical reaction. Number 1, presence of catalyst. Na ang catalyst ay any chemical substance na idadagdag natin siya sa reacting na mga substances din and mag-speed up ang reaction. Number 2, temperature. You know that paano mag-speed up yung temperature ng reaction? Tataas yung kinetic energy. So magiging hyper, yes, yung ating mga molecules. Magbangga-bangga sila with each other. And since magbangga sila, that is contact already, magkakaroon ng chemical reaction. And lastly, we have here the concentration. Siyempre, pag mataas ang concentration, maraming molecules, maraming particles yun. Tataas yung chance of contact. And that will speed up the rate of chemical reaction. Okay? So pag nagdali ta sa laboratory, ma'am, gusto na to mag-react dayon ang mga substances, mga chemicals natin, you may use or you may utilize the 3 factors. Either you add the catalyst, you heat the substances, or you add more concentration. Okay? Sige, any question on that? Yung oras na basig mag-overtime ko. Ay, wala pa din. Okay? Wala? Wala question? Sure na? Sige, we have the law of mass action. Let's talk about this. It's one of the laws na available sa chemistry. So itong law of mass action was formulated by 2 Norwegian chemists. We have Goldberg and Wage. That was long time ago, 1864. Ano sinasabi ng law of mass action na to? It states that the rate of chemical reaction is proportional to the active masses of the reacting substances present at the time. Ano ibig sabihin yan? Sabi niya, it's actually talking about the concentration. Kapag ganito, meron ka daw maraming particles, active masses, or mataas yung concentration mo. Yan yung ibig sabihin ng law of mass action. It is directly proportional, meaning tataas din daw yung rate of chemical reaction. Yan lang yung ibig sabihin ng law of mass action. So dito nag-start yung mga factors influencing the speed of the chemical reaction. So again, when you say active mass, it is referring to the concentration. So gaano karaming particles, gaano karaming molecules ang present sa substance mo, that will determine, that is directly proportional to the rate of the chemical reaction. So this actually shows class the relationship between the concentration of the reactants and products before and after a state of equilibrium is reached. So, di ba ito yung ating mostly chemical reaction. Meron tayong substance A, ipapareact natin with substance B, we will form a product. So pag marami ang substance A, marami din ang substance B, mataas yung kanilang concentration, malaki yung chance na magka-contact yung mga maraming particles. So mabilis mabubuo yung products. Okay? Product or products. Depende kung ano yung mabubuo. Okay? That's the law of mass action. Now, syempre, kung gusto natin mag-speed up, ayok magbasa sa explanation of the law of mass action. Ang sabi lang kasi dito, if i-double mo yung concentration ng example A, wait lang ha, isusulat ko siya. So example, this is substance A here. Originally, meron kang isang molecule. Tapos meron kang substance B, isang molecule lang din. So magkakaroon sila ng contact. Pag nagkaroon sila ng contact, there will be chemical reaction. Pero kung i-double mo daw ang concentration ng substance A, so dalawang molecules na yon. Okay? And then you have substance B. Tapos dinoble mo din ito. So syempre pwede siyang mag-contact dito, pwede din dito. Itong isang molecule ganun din. Magko-contact sa both molecules ng substance B, yung reaction class, yung speed ng reaction will increase twofolds. Madodouble din yung speed kasi malaki yung chance na magkaroon ng contact yung mga molecules, yung mga particles ng mga reacting substances natin. Okay, so itong sinasabi niyang illustration, dinraw ko na kanina. Na yung mga paths of collision, yun yung mangyayari. Pag marami kang molecules, ayan, sample 4, marami ka ding path of collision. So aside from partner-partner sila, maraming pwedeng path. Okay, lahat sila pwede magkaroon ng contact with each other. And then again, that will result to a chemical reaction. Okay? Now, how about the law of chemical equilibrium? Kasi mass action yun kanina. Ibig sabihin nun, pag marami ang concentration, malaki ang concentration, there will be high or mataas din yung speed of chemical reaction. Sa law of chemical equilibrium class, equilibrium means, it comes from the Latin word equus, meaning equal, and libra, which means balance. So ito yung law that states na for us to achieve equilibrium class, the rate of the forward and the reverse reactions have to be equal. Kailangan pantay. Kung mag-react ang reactants, kung gano'n sila kabilis mag-react to form the product, dapat ganun din yung reverse reaction. Yung mga products magre-react with each other to form the original reactant. Dapat parehas yun ng time, ng speed of the reaction for us to again achieve chemical equilibrium. Now please take out your calculators. We have calculators there. Kasi merong computation itong chemical equilibrium. If you want to know yung chemical equilibrium constant of a substance, we are going to use this formula. Okay? Sige. So, ito yung example chemical reaction natin. AA plus BB equals CC plus DB. Okay? Now, paano ma-compute yung chemical equilibrium constant? Constant ang tawag natin dito. Ha? Please take note of this formula. Product over the reactant. Okay? Ganyan lang siya. Product over the reactant. So if you have two products, you just have to multiply the two products and divide it sa dalawang products. Now, this bracket class in chemistry, This is talking about the concentration. Okay, concentration of the first product times the concentration of the second product divided by the concentration of both reactants. Okay, yan yung nakalagay ha inside the bracket. Now, ano yung small letters dyan? Yan yung coefficients. Meaning, si coefficients will be used as an exponent. Okay? So, exponent yan. Ano ibig sabihin ng coefficient? I believe you saw a chemical reaction na merong coefficients. Like, you have magnesium reacting with oxygen. This will give you magnesium oxide. Diba, nagbabalance tayo ng chemical equation in your high school days. Meron ito, balancing. Kailangan balance. I mean, kung ilan yung molecules on the reactant na side, ganun din dapat yung sa product na side. Diba, if we balance the equation, like we place a number here beside the chemical formula. Okay? So, just like this one. This is already balanced. We have 2 magnesium on the reactant side. We also have 2 magnesium here sa product. And dalawang oxygen, 2 times 1, ito siya. This is considered 1. So, dalawa. And then ito, dalawa din. So, ito class ang tinatawag natin na coefficients. Okay. Ano nangyari sa pen ko? This is coefficient class. And ito, we call this a subscript. Okay? But in the computation of chemical equilibrium, again, in the computation of chemical equilibrium, we are going to use this formula. Products ang sa taas, you have the concentration of each product, you raise it, you use the coefficient, if ever merong coefficient, as exponents, and divide it sa concentration din ng reactants raised to the power of whatever coefficient they have. Siyempre, kung walang coefficient, just like this one sa oxygen, this is considered 1. So, pwede nang wala dyan sa equation. Okay, coefficient will tell you how much molecule of this substance is present in the chemical reaction. Again, coefficient tells us class, this refers to the number of molecules present in the chemical reaction. So just like this, you have 2 magnesium, it means dalawang molecules of magnesium. Yung subscript naman refers to the number of atoms of that certain element present in the equation. So for this, in this case, we have 2 atoms of oxygen. Okay? Present in the reaction. Sige. So let's have an example. Ito na yung diniscuss ko kanina na this is the explanation kanina. But let's have an example. Example, we have this formula. Nitrogen plus hydrogen. Remember, both of them are members of our so-called diatomic molecules. Nasabi ko ba sa inyo last time itong diatomic molecules? Tama ba? Yes or no? Murag yes na murag no? Nakalimot? Kalimot na ta? Yes, nasabi ko. Diba ito yung bridge, no? Ito yung mnemonics natin. We have elements class na if they are uncombined with another element, they will exist as diatomic, dalawang atom. So always silang ganito. C is chlorine. Okay? So in this case, kagaya ng oxygen kanina, napansin nyo, nilagyan ko ng 2, O2. Kasi member siya ng diatomic molecules. Okay? So we have another example here. Nitrogen, uncombined with other element, automatic magiging N2. Mag-exist siya as diatomic molecule. Okay? Nitrogen, magre-react with hydrogen, yielding NH3. NH3 is ammonia. Okay? Again, this is NH3, this is ammonia. Now, if we want to compute for the equilibrium constant, mag-i-equal, di ba when you say equilibrium, chemical equilibrium, the rate of the forward and the reverse reactions should be equal. So if we want to know the chemical equilibrium constant, ano nga yung formula natin? Product
over reactant.
over reactant. So kung isusulat natin siya class, this will become Ke, ano yung product natin? Ammonia. Ilalagay natin sa loob si ammonia. Wala siyang ano, no? Ay, is this a balanced chemical reaction? That's my first question pala. Kasi hindi tayo makaka-compute ng correct chemical equilibrium constant if this is not a balanced equation. Balance ba? Sulat ko siya sa baba. N2 plus H2 equals NH3. How do you balance a chemical equation? Check mo ha, both products and reactant na side. This is the reactant side here. We have 2 nitrogen, we have 2 hydrogen. On the other side, we only have 1 nitrogen and we have 3 hydrogen. Is that balanced?
No.
No. So what are we going to do? We're going to balance this equation. How do we balance an equation? We assign coefficients. Trial and error ito. Wala tayong sinusunod na rule or na guidelines in balancing equation, yung steps. It's just trial and error. Okay? You just try to place or write coefficients here and then i-check natin kung mababalance ba. So what do you think are we going to do here? Kung ako ito magbabalance, lalagyan ko siya ng 2 dito. So 2.
Ma'am.
Okay, sige. Lagyan natin siya ng 2 ha. So therefore, yung nitrogen, dalawa na on the product na side. Sige. This is considered 1 ha. So 1 times 2 is 2. What happened to hydrogen? 2 times 3. Imumultiply natin ang coefficient ha and ang subscript. This becomes 6. So balance na yung nitrogen, yung hydrogen, hindi pa. So what are we going to do with hydrogen on the other side? Are we going to place there sa tabi niya para maging balance siya? We should place 3 here. Okay? Yeah, trial and error ito. So 3 times 2 is 6. Are we good now? Is this balanced?
Yes.
Okay, very good. So this is our balanced equation. Now if we're going to compute for the chemical equilibrium constant, we will be using this one. Sabi ko kanina, you will be placing the concentration of the substance here inside the bracket and the coefficient will become the exponent. So lalagyan mo siya ng 2 sa taas. Okay? And then, divided by the reactants. Isang product lang ang meron tayo ha, ammonia lang. Pero we have 2 reactants. The first reactant is the nitrogen. Meron ba tayong coefficient kay nitrogen? Wala. So that's automatically 1. No need to write 1 there. Just place N2. But for hydrogen, meron tayong coefficient. So this is 3. Okay? So this will be the equation now to compute for the chemical equilibrium constant of this equation. Okay? So do not forget product over reactant. Any question? Baka may gusto kayong i-clarify. Wala. Sure. Parang yun. Sige. So let's have this one. There are cases, class, that ito yung given. The computation of the chemical equilibrium constant. And ang kailangan yung gawin is to write the chemical equation. Okay? So are we going to do that? Diba? Always, class, in the computation of chemical equilibrium, product over the reactant. So, ito yung reactant natin. If we are going to transform this into a chemical reaction, magiging ganito siya. NO, and then meron siyang exponent na 2. Remember, the exponent na 2 is its coefficient. Plus, another reactant here, the H2. Meron din siyang exponent, so meron siyang coefficient, and that is 2. This one is a reversible reaction. So product ang nasa taas. Ito yung mga products natin. We have the N2. Ayan, N2. Walang exponent, so automatic that is just N2. And we have water. Okay, wala din siyang exponent. So as is, ito. Okay? Parang hindi ata ito balance. N2H2, 2NO. Yeah, hindi to balance. Bakit hindi to nag-balance? Dapat balanced equation ito. Nawala yung... Let's try to balance. Hindi ko pala nalagay yung coefficient ng products dyan. How do we balance this? N, O, and H. Tatlong elements. On the left side, we have nitrogen 2 times 1.
2.
That's 2. 2 times 1. We
2.
also have 2. For hydrogen, 2 times 2.
4.
4. On the other side, we have 2 nitrogen, 1 oxygen,
1.
and hydrogen, we have
2.
Shall we do?
Balance po.
Ano yung gagawin natin? Ano yung ating lalagyan na coefficient?
Mag-add ng 2 sa H2O, ma'am.
Okay, let's try to add 2 here. So this becomes 2 times 2.
4.
Hydrogen will be 4. 2 times 1 is
2.
2. Is this balanced now?
Yes po.
Okay, balanced.
Yes po, ma'am.
So, hindi pala nasali dito, pero may coefficient dapat yung water. Okay? So that's how you transform, class, a chemical reaction to compute the chemical equilibrium, or the other way around. The chemical equilibrium constant equation is given, and then this is how you transform it to a chemical reaction or chemical equation. Just do not forget, it's always product over reactant, and the exponents present there are their coefficients. Okay? Sige. So next meeting, we will continue with this one. Meron talaga itong computation. So just like this one, nasaag ang ako ang arrow. The arrow should be placed here. This is a reversible reaction. So for the reaction, hydrogen plus iodine yielding hydrogen iodide or hydroiodic acid. At equilibrium, the concentrations are found to be. Ang hydrogen daw, ang concentration niya is 0.106 molar. Si iodine naman is 0.035 molar. And ang mai-yield na product is 1.28 molar. So ang mangyayari, we will be computing for the equilibrium constant. So always go back to the product over the reactant. Okay? So yung mangyayari dyan, product is isa lang, HI squared kasi dalawang molecule yan. And then, we have dalawang reactants, H2. Wala siyang wala siyang coefficient times. Yung isa pa, iodine. Wala din siyang coefficient. So we will try to solve this next meeting. We will use class these values. Ipapalit natin siya dyan. Okay? Pero next meeting na kasi I don't have time left. So we have problem solving next meeting, and then we will continue with the other lessons. Do you have questions so far?
Nakausura ko ulit.
No, maka-mute mo kayo, matito sa inyong mga dira.